So this is going to be the second video for Note 75. In the first video, we covered question number 1, which is a quadratic word problem. Now we're going to cover question 3 and question 4. So question number 3, part A. Let me zoom on in here. We're looking for an inverse. So remember, you're going to do it in 2 steps. Swap X and Y. There's my goofy little and sign. They get worse and worse every day. And then once you've swapped them, we're going to solve the equation for Y. All right, so if we look at our equation here, if you need to remind yourself g of x is y, go ahead and do that. So when we do the swap, that becomes x. And then in the original problem is 3x, that becomes 3y minus 8. Let's go ahead and restart solving this for y. So that means I'm going to add 8 to both sides. So let's see, x plus 8, that's a horrible x, there we go. And then that equals 3y. I'm going to go ahead and divide both sides by 3. So y is equal to x plus 8 over 3. And then in function notation, right, you had g of x in the original. So this is going to be g inverse of x. It's going to equal x plus 8 all over 3. And that is your inverse for part A. All right, so let's go ahead and slide on over to part B. Again, if you watched the video for note 74 on inverses in domain, you're going to know this is going to be a big step up. Okay, big step up. So we're still going to start the same way, right? We're going to replace x with y, replace y with x. So x equals 5y plus 2 over y minus 4. All right. Not a huge fan of this. It's got a big old fraction in it. So let's go ahead and it's going to seem weird, but I'm going to put an extra fraction in here to then go ahead and get rid of the fractions. So this is to help me remember to do cross multiplication. All right. So the easy cross is going to be 1 times 5y plus 2. So that's simply, I'm going to say simply, but that is just 5y plus 2. The other cross is x times y minus 4. So x times y minus 4, I'm going to need to distribute that. So 5y plus 2 equals xy minus 4x. I'm not a huge fan of the fact that this, of course, has y terms on both sides. And so what I'm going to do is I'm going to move one of them. Doesn't matter which one, but move one of them to the other side. So let's go ahead and subtract a 5y from both sides. The exact same time I'm doing that to move my y term to the right side, I'm going to go ahead and take the non-y term, in this case minus 4x, and move it to the left side, right? These are unrelated to each other, so I am welcome to do that. So I'm going to add 4x, add 4x. Okay, so let's see if I can combine and collect and put this all together here. So 5y minus 5y is going to be gone, and I'm left with 4x plus 2 or 2 plus 4x. It won't matter. And then xy minus 5y minus 4x plus 4x is going to cancel. I write huge, so let me go ahead and slide this up. All right, now, why did I do this? Well, I got the y terms on one side, because now that both the y terms on one side, I can factor out that y. And the reason I want to factor out the y is because when I'm trying to solve for y, I want to get it to a point where I just have a single y, right? This single y right here, I can now get rid of this piece of this, right? This is y times x minus 5. And I know how to get rid of a multiplication problem. I can factor that. I can, not factor, but I can divide the factor out, all right? So y is equal to 4x plus 2 over x minus 5. All right, but let me go check my original notation here. It was g of x. So if I do g inverse of x, that's going to equal 4x plus 2 all over x minus 5. All right, so we did an inverse. Lots of steps with this one, especially, I mean, when you look at these two problems, they're both the exact same directions, right? Find the inverse of the function, but this function is much easier to deal with than that function. All right, so 2 steps here, 2 steps here. lots of steps from here to here, right? But the nice thing is, right, if I look at the work that I just did in question number 4, part B, that matches this question down here. I don't even know if it was 4, if it was 3. It was question 3B. All right, so let's talk about question number 4. So let's define the domain and range. So, of course, let's talk domain. All right, so domain is anything that is a possible x value. And in this particular problem, everything is a possible x value except any numbers that make our denominator equal to 0. So I'm going to purposely make that denominator equal to 0. And I get a problem value of 4. So my domain is going to be everything, negative infinity up to 4. I'm going to exclude 4. And then go up to infinity. And the way I show the exclusion for 4 is parentheses on both sides. And that basically means that every value up to 4 and every value right after 4 is totally fine, but 4 itself is excluded. I also want to know the range of this, but remember the range of the function is the domain of the inverse. And so we found the inverse over here. So I'm not going to reinvent the wheel. It's right here. So what I'm going to do is I'm going to do the exact same thing. I'm going to look at this denominator and see what value I need to exclude from the domain of the inverse. And that would be the value of, let's see, 5. Right? So x equal to 5. So my range, right, because range of the function is the domain of the inverse, it's going to be everything up to 5 and then 5 to infinity. All right, and that is the end of this question, right? We found the domain and range. So that's going to be the end of the video here. All right, that was the finding inverses and range for these particular functions. As always, let me know if you have any questions or concerns, and I will see you in the next video.